I'm working on a lot of different projects right now, and there isn't too much overlap between them. There's one thing in particular they all have in common, though. They're all using TypeScript. There's a lot of other overlaps, but the TypeScript is the one key piece. Maybe they're not using it for everything, but most of them are using it for a lot of things. And because of that, there are frustrations I've been having with TypeScript. One of those is try catch. I don't think this is a good pattern. You guys know I don't love Golang, but at the very least, they got some things right here. They kind of force your hand and make you handle errors. TypeScript doesn't care. Errors aren't even typed. Your returns are. Your errors, who knows? You call a function, it might error, it might not. You have no way of knowing unless you've read all of the code that it has and it calls. No more. I am too tired of this. And as of early last year, I think, I solved it. I wrote a pretty jank solution, but it's actually pretty good. I posted it on Twitter and people loved it. So I'm going to take some time to break down this interesting code, what it does well, what it does poorly, what other options you have, and most importantly, what you should be doing about the errors in your code. Because all of us as TypeScript devs need to be handling our errors a bit better, unless you're Ethan Nicer, but all the rest of us should probably be doing more of this. Sadly, wrapping errors with viral tweets doesn't pay the bills or my team, so we're going to do a quick sponsor break and then dive right in. Today's sponsor is something I have to admit I'm a little bit late to. Well, I'm not late to CodeRabbit, but I am definitely late to this docstrings feature because it's really cool. We've all been here before. You just finished a really hard, annoying PR, got a bunch of changes approved, but there was one comment you still haven't resolved. Add docs. It's not fun. We've all been there, especially once you have to start documenting every function on your APIs and whatnot. Yeah. Not great. This is part of CodeRabbit's new finishing touches features, and they're really cool. All you have to do is type @CodeRabbit, generate docstrings as a comment on the PR on GitHub, and they will automatically make a PR handling all of that for you. And the reason I said I'm late to this is because when I searched on GitHub, there are already almost 11,000 pull requests that are doing this. I'm going to literally click a random one that's not even merged. Here's add docstring to MMC. Let's see how it did. Look at that. It added like useful updated comments for the functions in here. Also fixed the comment syntax because the double star here is the semantically correct way of doing this. Semantics aren't really a thing here. You get what I mean though. It's actually super cool to have this automatically go through and leave useful comments about what these things do. Not because you need to see the comment right above the code here, but when you have an LSP like VS Code does, you go to another file trying to call one of these things, you just hover over it, and now you can see exactly what it does. Those good descriptions of what functions do in VS Code come from here, and now you can just generate them with one command. That's separate from the fact that it will do all your code review for you, by the way. It actually seems like here they had them code review the docstrings that it added, which is hilarious. And actually really cool. I'm still amazed how many bugs we've avoided because of using CodeRabbit. Check them out today for free at soydev.link/CodeRabbit. I couldn't help myself but make a few jokes. I was surprised so many people liked this. I thought it would do well, but I basically tricked 3,000 plus JS devs into admitting the fact that Go does some things right. Because Go's pattern is whenever you call something, you have to deal with the error before you can use the data. The difference being Go is whatever the opposite of type safe is. It's not dynamically typed. It's like question mark typed. It just does what it feels like and you hope for the best. Real languages have types. And yeah, this is nice because at the very least, the data is typed. I'll show you guys how this works. I actually put the code here. So if anybody wants to go grab it and play with it themselves, feel free. We're going to copy this, throw it in TS Playground. So here I have that code. We have our try catch function. Let's make a fake async function. Do math. This function has a math.random call. We'll just assign this const value equals math.random. If value is greater than 0.5, throw new error too large, else we return value. So this function, as far as TypeScript's concerned, just returns a number. So if I use this somewhere, like const some data equals await do math, console.log, some data. As far as TypeScript's concerned, some data's a number. If we do our little shicky 2/ here, we'll see const some data is number. That is bad because right now, half of the time, we're actually not getting data, we're throwing. And if I change this to be greater than -1, now this code throws 100% of the time, and we're not handling that here at all. As far as TypeScript cares, number is what some data is, and some data always exists as far as it knows. So what ends up happening is if this isn't some data, it's because there's an error that was thrown. And now, because we're not handling it, it gets thrown up. And whatever called this hits the error instead. Since we're in the top scope, we're not calling this in a function, everything falls apart. So what do we have to do? If we know this can error, we can try to do it. We can assign the value in here and then catch error, console.error, error. But now that value doesn't exist. Now we don't have some data because it was defined in this block. I could move all of my code into the block, but that sucks. Having to be multiple indents in, especially if you're calling multiple async things. Okay, let's say we want to add some data to another do math call. Then I can try again. Const more data equals await do math console.log sum of some data plus more data. Catch again, error, console.error, error. What's even worse here, like this is already bad. See how tabbed in we are for this basic math we want to do? What's even worse is if we rethrow this error, then it gets caught here and we lose track of what's going on. We have no way of really knowing where an error happened unless we manually handle all of this. This is horrible. No one should have to write code this way. So here's what I did. Equals, wait, try, catch, do math. Now we have some data, which is number or null, and error, which is error or null. And watch where this gets really, really fun. We're going to move this into a function because I want this to be more realistic. We put this in here. If error, return error unable to process. I'm going to put an async here. And now that we've escaped on this error case, some data is a different type. The type changes to number. Before we check the error and handle it, it's number or null because we don't know yet, because we haven't checked if there's an error yet. If there is an error, we return. Now we actually know this exists. Let's do that extra layer we just had too. Const data, more data, error. This is the one annoying. So you said it should be an array. It makes the types a little annoying. I would be willing to cave, but yeah. Error, more error. I'll change this to be some error. Let's be consistent. Equals await, try, catch, do math. And if I was to try and add these, we'll get an error because more data might be null. You can't add a null to a number. So if more error, return error unable to process. And suddenly this is safe. Gonna clean this up a little bit because I want you guys to honestly tell me that this isn't 100 times better than whatever the fuck is happening here. It's not one of those like, I have opinions, you have opinions, they differ. One of these is just waiting for a bad change that passes code review to cause tons of problems. The other one actually describes what's going on. This is an obvious, significant win. Thankfully, most of y'all appear to agree. It isn't 100 times better, it's 1,000 times better. Yeah. To be clear, though, this solution is meant to be a bare minimum. I don't think try catch is the solution to almost any problems, especially once you're in a async world. I think, at the very, very least, for almost every codebase I've ever been in, try catch shouldn't be a thing you do with try and catch. I've had so many bugs in so many projects that are weird nested try catch blocks doing things that don't make sense because humans do not think that way. It doesn't work. So if you're already using try catch blocks, this code here, which again is published in a gist that is linked in the description, it is 25 lines of code that will make everything you do significantly safer and a lot easier to handle these errors. I would highly recommend, as a bare minimum, you copy this code. I get nothing for it. I don't care. I'm not doing this. I want to be popular for getting my code into people's code bases. I think this should be set as a bare minimum for how you handle errors when you do weird async stuff. That said, it is absolutely the bare minimum. And recently, I've been putting work in to do better. There are two specific solutions I want to talk about. As I said, we have the lowest tier path, which is what I did. So fine tier, Theo's try catch wrapper. I think it's good, but it's not the only solution. I want to talk about two others that are really important. Those are effect.ts. There's a lot of other things to call effect. I think they just call it effect now because it kind of is its own language. And Neverthrow. So given these three options and this spectrum, effect rewire your brain or be born as Ethan Nicer. Those are basically your only options. Low effort, low friction, easy to just drop in your codebase and get back to work. You don't even need to npm install. You just copy paste. Try catch. And then Neverthrow, which is an interesting in-between of the two. I think Neverthrow will be the easier to digest. So now that you hopefully understand why this is good, we're going to move on to why I've been using Neverthrow more. Neverthrow is a pretty literal name for what the package is. It is meant to encourage the idea of result type. The result type is a really important thing to understand. What I did with my playground here and with my helper function there is kind of brute force a result type into more traditional TypeScript by defining a success, which is data exists, error is null, as well as defining a failure, where data is null and the error exists. Now, a result is either success or failure, and the try-catch function returns a result, which is either a success or a failure. Do you see where we're going here? Right now, the error only happens via try-catch. But what if, instead of just blindly try-catching here and not even knowing the type of the error, it just is error unless we manually pass something else? What if, at all levels, we returned something that looked like this? What if instead of just returning if the data's there and throwing if it's not, we went out of our way to make sure at every single level, at every single layer in our code, we always returned. We never threw. See where the name comes from? The point of Neverthrow is to keep you from ever using throw calls. Never throwing, it's literal. Instead, you return error. Here is some actual code inside of T3 chat. This code originally was a mess. We introduced a try-catch wrapper. It helped a ton, but it was so complex that it needed more. And I wasn't ready to bite the effect bullet, as I'll describe more in detail soon. So I decided to give Neverthrow a real shot for the first time, hoping I could use it in a relatively minimal way. And I kind of could. This is the verify request function. This takes in an already validated through Zod request and makes sure the things you're requesting when you send a message are allowed. This checks for things like, are you an authenticated user? Are you a subscriber? Did your reCAPTCHA token check pass? Did it fail? All of these things are handled here. And if we hover over what verify request returns, it's a result that is either verified request params or verify request error. And if we go to the route TS code where this is all being called, you'll see here, verified request is await verify request validated input. If verify request dot is error, I grab the error. And here's where it gets really cool. Error.type is strictly defined. It has to be identification failed or model failed or request too long. It has to be one of those because they're not being thrown, they're being returned. It says we are always returning error or returning a result as we do down here, but we wrap it with OK. Now we know the result has to be one of these two things. It has to be an error, and if it is, it has to be one of the things contained with an error, and if it's not, it has to be OK. And if I return anything that isn't error or OK wrapped, this doesn't work. So if you're working on a system like we are with this, where there's a lot of different layers things can fail, and we want to make sure that we know what error happened where, so that I can send the right message down to the user, so I can return something specific if the CAPTCHA failed versus your auth failed versus the model's offline versus you requested a model that you should be a sub for, but you're not a sub. Now I can return the right message to the user depending on the condition, because I know every single condition it can be in. Where this gets really fun is when you nest things up and down. So this function always returns error or OK, but it also calls other functions, and those functions might throw too. So here in verify requested model and features, I went and made changes so that it will always return error of some form or OK. Now I know that when I've done this, that it has to be in one of those states. So if model verification isn't an error, then we're good to go. And if it is an error, that I can forward up the thing that describes what that means here. I could just return the error itself here if I wanted. If I wanted to just return like the error that we got before, I can. Model verification dot error. Now it's bad because verify model error doesn't match the type of the errors this returns, because this returns a verify request error. I could change this to be a verify model error as well, but I chose to let this function return something different. because I have to. I have to make a decision because this errored. And if I don't, then I can't use the data. And this is the benefit here. Now, when I have a function that can error, I can't just call it and pretend it didn't error. I have to be very explicit that it didn't error. And to everyone in chat saying this is way over-engineered, I envy you. I genuinely envy you guys for having never worked in a code base that is complex enough that you're drooling over this. Because I've worked on a lot of things like long-lived services such as Twitch, things that use a ton of weird APIs and browsers and Electron, things that could error all sorts of different ways. It sucks. You need a way to know what went wrong. And as your code base gets bigger and more things can go wrong, having your code be very explicit about what right looks like and all of the things wrong looks like is a huge win. This is a cool solution because it's also not as aggressive as other alternatives. I'm not going to say it was drop-in. It took real work to make these changes and make this code work well this way, but it does. It's actually very nice now. It's significantly more readable, and at every single layer, we know exactly what is happening. And when you have code that can return 40 plus different types of errors, it is so, so valuable. This is too many levels of indirection. What you did with 25 lines was way better. No, because we don't know what error it is. And that's the thing. At every layer, we lose the error. If I did this in a different way, if I did this using my try-catch wrapper, we wouldn't know what the error was up top. We would just get error back. And now I can just return that. What we were doing before was if error.includes special string, return this case. Or if error includes this special string, return this. We're still doing a little bit of that, but it's not if it includes it. It's if the error type is this one specific thing. Now we can do exhaustive checks. I could even do a switch statement here that is exhaustive because we know error has to be one of these two options. Either the rate limit was hit or our code checking the rate limit errored out some way. That is awesome. That is huge. The fact that I can identify the difference between error types means this code can behave in ways that make significantly more sense. Huge win. I was skeptical too, because I literally wrote an alternative that's used all over this code base. Here I'm using it on the client. Error, await, try catch, do event processing. If error, I throw an error that I couldn't process the event. This is for Stripe checkout stuff, just useful debugging things for us. Previously, this would have just, and I almost certainly did this, it was just like this before, and then it would throw, then the user would get an error in the browser. Now they don't. It might still have failed in a way that is important, but at the very least, I have a console log they can show me as we figure it out. I have my verify fingerprint code that uses it. I have my IndexedDB shim that does it. So when I try to sync the database from the server, I use this here as well. It is really nice for these one layer deep things. If the async stuff's only going down or up one way, this is fine. As soon as there are layers in nesting amongst the things that can fail, as soon as the failures occur and get more and more complex, it becomes more and more valuable to have a tool like Neverthrow. It isn't perfect though. I personally don't love how it handles async stuff. Here's where I find the Neverthrow pattern to be a little rough. You can take a promise that doesn't follow the Neverthrow standard of always returning error or result, like get rate limiter, which as far as everything here is concerned, will always just return this all. Actually, I did change this. This is using Neverthrow, but it's async, so I can't just await and expect it all to be fine. There are other layers within it that can throw. So I wrap it with a from promise call, but here's what's really annoying. If I delete this and then, this seems totally fine and normal. I checked if it's an error. Cool. Const value equals internal rate limit dot value. What is the type of value here? Oh, it's a result type. I haven't confirmed what the contents are yet, so I can't unwrap it yet because it's possible this is in a state that isn't good because this async function, this get rate limiter, is returning okay or error. Now I have to unwrap that, so to speak, and that is what this and then did. And this is where the model starts to get annoying. The fact that when I start chaining things with async, each chained layer has to be unwrapped, which is what and then does. It's not just then. And then handles an unwrap and an error case as well. I hate this. I hate this so much. I also hate that whenever I'm heavily using Neverthrow, I have to do my least favorite thing. Return types everywhere. I don't like return types. If you don't know why I hate return types, watch my video on it. It's a little old, but they break things in TypeScript. They're not great. They make it easy to override things you don't want to. However, it's real important. They are still native to TypeScript. And this is where we need to dive into effect. Effect markets themselves as the best way to build robust apps, be faster, and all these other things in TypeScript. And a lot of the smartest people I know are effect diehards. People like Ethan Nicer, people like Julius contributing on our team. They're some of the best engineers I know, and they're all in on effect. If you want proof, you don't have to look very far. Here's the upload thing code base, the public one, the open source one. It has 60 plus imports. We're using it all over the place. It's super, super useful. We have benefited greatly from introducing effect to our code base for both the packages for upload thing as well as the infra for upload thing. The problem is that it requires a lot more buy-in. I'm going to make a weird comparison, and I hope this comparison helps emphasize how I feel properly. Back in the day, the web was just JavaScript modifying HTML. As our applications got more complex, we needed better solutions for it. And jQuery came out, which helped make those relationships between the JS and the HTML a lot easier. Things got more complex again, though, and other solutions were introduced to solve those complexities at certain points. But a specific important thing happened: React. When React dropped, they implied and kind of suggested that you can use React for the interactive parts of your website. So if you have like one component that needs to be more interactive, or a comment section or things like that, React can make that better. I don't think that's a good way of putting it. I don't think React is a very strong solution as a component in your web page. I think React is a good solution as the root of your web page. If your web page doesn't start with a React tag, it's not a great solution. And the benefits of React are much, much stronger if React is your application. There are other solutions that work better in those more granular, like deeper down use cases. And there's also ones that try to do that but fail, like web components. But React really expects to be the root of your app, and it is strongest when you let it be the root. React is best when you mount it as app, not as a button somewhere down. It works best when you mount it as the app at the top. Why the hell am I talking about React in a video about errors? Try-catch is fixing vanilla JS. I would argue try-catch is kind of the jQuery of the space. Neverthrow is more something like solid JS, where it can work at these different levels. You can drop it in. It has its quirks. It has its mental model you have to get around. But if you do, you can benefit greatly from it. Effect is React. I will fight day and night with all the effect diehards. They are much smarter than me, and they are probably right about a lot of things that I disagree with them on. They are not right that you can just add effect to a code base. In order to use effect, you have to first rewire your brain. And when you are done with it, you then realize you're wrong and have Ethan Nicer hop in a call with you and rewire it for you again, as poor Ben experienced, or you have any of the others from the team help too. We had a lot of help from Johannes when we were moving over to it with upload thing. Once your brain is finally correctly wired for effect, you can then go rewire the entire code base. You can't just move your code to use effect in some places. You yourself first have to make the move and understand it. Then you can start rewriting your code base or building a new one using the patterns that it introduces. And those patterns are awesome. It is genuinely really, really cool. If we read through the Y effect, you'll see a lot of things you're already familiar with. We have an example of code here where if b is 0, we throw an error. You can't divide by 0, otherwise we do the division. The type doesn't tell you that this can throw, though. You just assume you can pass it these things and always get a result. But that's not true. It might throw. So now you have to wrap that in a try-catch block. With effect, you can do this very differently. Since divide returns an effect, now we have the condition b is 0. If so, effect fail with can't divide by 0. Otherwise, effect.succeed with the actual solution. You might be like, well, that's weirdly nested. Why are you returning a direct ternary instead of a function body like we did above? You don't have to, but I've seen a lot of effect code at this point, especially in our own code bases. I think effect users just hate brackets. And basically everything they write is a giant ternary like this where every single potential condition is handled and chained, which is cool. It just makes it very hard to parse if you're not used to thinking this way. You'll see what I mean when you start looking at more effect code, taking more advantage of the functional patterns in it, using things like pipe. Pipe lets you take the result of a function and pass it to the next one, and bubbles up the error if one of them has an error. So instead of writing this code as like const value equals effect.map, const value equals effect.flatMap, stuff like that, we don't even have brackets. We just have parens, and we pass the different functions through one at a time. This barely even looks like TypeScript at this point. And as you go deeper and you look at more and more complex effect code, it starts to look less and less like the TypeScript we know and love. Especially once you add crazy functionality like tap, which lets you run a side effect without changing the original value, which lets me, in the middle of a process, like here, I have the transaction amount, I want to log it, but I still want to have the amount for the next thing. Effect.tap returns the argument you passed, but lets you do other things. We're talking about a thing where console isn't even lowercase c anymore. They have their own console helper. Do you see what I mean when I say this consumes your whole app? It's a different way of thinking. And it's so different that Ethan just published a blog post, The Truth About Effect. I had you believe Effect was a TypeScript library, unlike FPTS and Neverthrow, etc., because it shifts work out of the data type and into the runtime. But it is a library still. It's not exactly accurate. In my defense, I didn't realize it myself until very recently. But with Effect days around the corner, it's time to come clean about what Effect really is. Effect is a language. More importantly, Effect is not TypeScript. Effect is a different way of doing TypeScript that is so different it no longer is TypeScript, the same way TypeScript isn't JS. Kind of is, but it is not fair to say TypeScript is JS. It is not fair to say Effect is TypeScript. Neverthrow is a lot closer to TypeScript. You have to use more of TypeScript in order for it to work the way it's supposed to, but it is much more so TypeScript. The goal of Effect isn't to be TypeScript. It is to take advantage of the ecosystem that TypeScript has and use it to make more effective language primitives and make code that is more reliable. The goal of all of these projects, be it my try-catch wrapper, be it Neverthrow, or be it the Effect ecosystem, is to make more reliable software, things that error less often, things that we can trust more. Because the quality of software is plummeting, and AI is not helping. It is actually hurting here, because it's too easy to write too big of code, and people don't like reviewing it. And as a result, we slowly get more and more errors and more error-prone software. Tools like everything I'm describing here are how we fight back. It's also worth noting this blog post is a reference, it's a great reference, to an old gist from our friend Rich Harris, creator of Svelte. The truth about Svelte. Svelte is a language. I adore the fact that Ethan made this reference. I think it's really cute and a good shout out that is acknowledging the same correct, important details. So that's why I didn't adopt Effect. I want to be very transparent with this. I haven't had my full Effect click moment. I have had my click moment with everything else on this page and most of the other things I've talked about on this channel. Effect is such a massive pill to swallow that I haven't yet. And honestly, part of why I adopted Neverthrow is so that I don't lose weeks of work being nerd sniped by Effect. I know it's going to happen. I know making this video is me getting closer to it happening. And I know I'm about to force a lot of y'all to go down this rabbit hole because I don't think you come back from it. Ethan, if you don't know him, has awesome videos on his YouTube channel, blew up as soon as he started posting. His first handful are deep dives on Effect. And as you see, I've watched them. I've watched them multiple times, actually. And it started to click. I see the value. I am just not ready to make the full move. And thankfully, he is not upset in any way, shape, or form about it. When I posted my try-catch wrapper, a bunch of people jumped in saying, oh, the Effect boys aren't going to like it. The reason I brought this whole tangent up is the real Effect bros love it because their goal isn't to get everyone using Effect. Their goal is to get everybody thinking about their errors. And the only reason you would look at all the things I've showed here and be like, that's not necessary, just try catch, throw it, who cares? Is because you're not thinking about your errors. You just let them happen. And when your software gets big enough and serious enough and complex enough, it's time to start thinking about those errors. If we think about this a little bit differently, instead of low to high, it's start to end. Try catch is a great way to start thinking about your errors, to be more cognizant of it, and to use them and return the right things when you hit them. Neverthrow is a great place to go when the layering of your try-catch wrappers is getting more and more complex. And you want to make sure the right error gets to the right place and that you know what the hell it is. Effect is when you want your code to never error again. You want to be sure at every single layer, every error case is handled, and you're okay with writing your own wrappers for things like fetch, using a complex wrapper for something like console, and getting super functional programming build, and going so deep in it that nobody else at your company that doesn't already know it is going to want to contribute to the code anymore. I say as somebody who's scared to contribute to upload thing now. Think of this like a spectrum of start to finish. And if all of this stuff feels unnecessary to you, just copy paste my wrapper, throw it in the code base, start using it a little bit more. And eventually you'll probably be where I am, where you end up here. And eventually, if the code gets complex enough, you'll probably end up there. And believe it or not, despite me not actually knowing how to use effect properly myself, I am the one who pushed it for the upload thing team. I am the one who made the introductions to Johannes and Ethan and all of that crew. And I'm invited to all of the effect meetups and everything because I know it is the right solution. I'm just not ready to learn it yet. So thank you for getting this deep into a video about error handling, deep enough that I don't mind exposing myself. If you hit the sub button, that'd be cool. I don't got too much else to say here. Just do something with your errors. Don't throw them. Things will only get harder if you do. Thank you guys as always. Please find some way to handle your errors. Until next time. One other thing I almost forgot to mention that I think is pretty important. Arthur made a proposal. I have a whole video about this one already, but I just wanted to bring it up here for try await syntax in JavaScript so that the JS standard itself allows us to have error value okay as the response. So we don't have to do the crazy try catch nesting. Just like build a try function or a try keyword that you can put a function call right after to not need the block. I'm okay with this, but you can also define this yourself as I showed. I don't think the web standard should go out of their way to implement something that's literally a 25 line of code helper or a 5 line of code helper if you're not using types. I don't think it's going to go anywhere. The other proposals were a little more chaotic. This one's a lot more digestible than the others were. It's a really good effort, and I would use it if it was baked in, but I don't think it is necessary. Just my thoughts on it. Anyways.